Good afternoon. Today's Tech Talk slot was unfilled, so I volunteered to give a short, light talk. We're going to take a quick survey of web technologies that seem to go out of fashion just to come back years later. The first thing I'd like to talk about today is full-page HTML transitions. In the days when everybody had dial-up internet and Internet Explorer was fighting to become the browser king, Microsoft included a feature that allowed any web developer to insert a meta tag into the document head that would cause Internet Explorer 5.5 or later to delay rendering until after a full page download had completed, including all of those painfully slowly loading images, just so that it could transition to that page with a PowerPoint-style effect like this. Here's what that used to look like. It was a slow and pointless experience, especially on dial-up, and this was rapidly considered a stupid effect to use. Years later, many modern websites feature some animation between pages. This is Squarespace. I recorded this in 2014. Watch the triangle underneath the header image as we navigate between sections. Notice also the URL, which is actually changing. You may have noticed something similar on GitHub. Powered by the HTML5 APIs and modern single-page app web frameworks, page transitions are back. Luckily, this modern incarnation speeds up browsing instead of slowing it down, thanks to a completely different technical underpinning than the one used by Internet Explorer. And it's fast because we no longer need to wait for images to download, and we're only transitioning between pages on the same website, not between two completely different domains. Our next zombie trend today is browser monopolies, sort of. Many of us remember these days when many websites proudly declared themselves to work only in, or at least work best in, Internet Explorer. IE6 really was the best browser when it was released, and remained so for at least some time. I hear a lot of boos, and I'm with you, of course. Its dominance was near total. Unlike Netscape Navigator, its competitor at time of release, it was included for free with Windows, which had a near monopoly in personal computers, especially in corporate America. Nothing stopped webmasters from coding specifically to that browser. However, a resistance grew, as did support for web standards, defined by a consortium instead of just one company. Eventually, Firefox was released, and it started stealing market share from Internet Explorer, further eroding the ability to assume that website visitors were using IE. Contributing to a trend away from that browser, Microsoft abandoned investment in it for the better part of a decade. Specifically, IE6 remained the latest version available for 8 years until Internet Explorer 7 was released in 2009. And IE7 wasn't even that much better. In the meantime, Apple had forked KHTML to create the excellent WebKit engine powering its new browser, Safari. And Google had forked that to create Chrome. All of this meant that Internet Explorer was no longer the best at anything, or even the easiest browser to support. It still didn't even support semi-transparent PNGs, for example. Microsoft's browser monopoly died slowly but decisively. The trend towards mobile has further shifted the balance. No best-smelling fart... That didn't happen when I practiced this talk. No best-selling smartphone in the Western world features anything other than a WebKit-based browser. So today, on desktop and on mobile, we have a near monopoly of browsers that are either Safari or based on a fork of Safari, including Chrome and browsers like Samsung's. In other words, the WebKit browser engine seems to be everywhere. So is everything terrible again? I don't think so. The future is not going to be quite like the past, although we are not without problems. It's true that once again, many developers feel tempted to test in just one browser, Chrome, and call it a day. But we still need to test in Firefox and Edge. And it's also true that there isn't even one WebKit, as Peter Paul Koch would readily tell you. Safari and Chrome certainly have developed their differences. And beyond that, the situation on mobile is quite fragmented. Many smartphone companies have developed their own odd little forks of WebKit that they ship as their mobile browser. These can have unusual differences, and companies that are really invested in web on mobile have labs full of test devices. Further mitigating the danger of a near monopoly in the browser space is that progressive enhancement has really caught on, as well as coding to the standards. By this, I mean code that works fine with a particular new browser feature. Works fine without that particular new browser feature, but that will use it if available. So small differences between browsers aren't really a problem. Our next topic is server-side rendering. This is all about where the web page is being assembled. Are you sending a full and complete HTML document from the server, or are you constructing it with JavaScript on the client? Of course, it used to be that server-side HTML rendering was your only real option, at least before web apps became all the rage. Backbone, Angular, Ember, React. Now, everything seems to be becoming a web app. Of course, not everything was a web app, but that's where the excitement was. Some more time passed, and as the satirical Twitter account Horse.js puts it, the pendulum appears to be swinging back towards server-side rendering and models, even amongst the cool kids. And why should we take a jaded horse seriously? Because of what this other parody Twitter account says. BuzzFeed.js tweets, "Here's why you should start taking Horse.js seriously." So let's just update our little chart. Why render on the back and the front ends? Well, despite the fluid user experience client-side rendering provides, there are distinct advantages to rendering on the server and the client. In particular, server-side rendering is extremely advantageous for search engine optimization, not to mention a quick initial download and render of the web page before all of your JavaScript loads. Luckily, there are now web technologies that allow us to code our web app once and render on both the back end and front end. Fast on load and on user interaction is the holy grail. In fact, this is the case with the Squarespace example that we saw earlier. All of those sections that had their own URL and then we were animating between, if you go to that as your first page, that will download in full HTML and render and then load more JavaScript to quickly transition to the other pages. Rails includes turbo links now, and Node.js has really contributed to this being possible as well, as has React, which can be rendered on the browser or on the server using render to string. So these modern technologies allow us to have dual server-side and client-side rendering of our application. A lot of big players seem to be using such an approach. GitHub, Yahoo, LinkedIn, Instagram, Netflix, and others have all either experimented or deployed such a hybrid approach. And while such a setup is not universal, it's decidedly cool. Our penultimate trend today is putting on-click on things. Old school JavaScript was sparingly included in web pages, and once was mostly limited to a number of global functions invoked with onClick, an HTML attribute that ran some JavaScript. This worked fine, but as web pages grew to be more complex, with more potentially hundreds of clickable items on one page, this became pretty unwieldy. So we had to get rid of that. jQuery moved us towards some smaller number of listeners capable of responding to click events and other events on any element on the page. This slide shows us how one might use jQuery to set just one listener on the root of a document, which would trigger for any click event and conditionally execute our function if that event occurred on an element with class zap. Even if we saw hundreds of such elements on our page, we would only need to set one listener, and this was a very performant pattern. OnClick started coming back when Angular got to be fairly popular. Here we can see an ng-click directive directly on an element, right there in the HTML, which tells Angular to execute some code on click. Its performance is no better than the original onClick as far as I can tell, although no longer would developers need to be forced to execute global functions, as Angular is providing scope for these. Now tools like React automatically turn what look like click handlers on an element into an efficient single listener. This isn't actually HTML, it's JSX, which gets turned into JavaScript before eventually creating DOM nodes in the browser. The onClick parameter is intelligently applied behind the scenes. We use it in a small, reusable, specific view called a component. And React is smart enough to use just one listener for a whole group of similar components. This gives developers readability, debugging power, and straightforward maintenance because it's easier to reason about when all your related code is in one file as compared to when you have a distant, disconnected event handler. We all get all these benefits without sacrificing the performance of that jQuery style document listener approach. So thankfully we can see that this trend only looks like it's coming back. Our final topic today is HTML. Now, of course, HTML never really went away, but it was deeply uncool for a while when XHTML was how a web developer showed that he knew his beans from his potatoes or her Zerg from her Protoss. How exactly was XHTML different from HTML? Well, its biggest selling point seemed to be that it was strict. When you copied and pasted old HTML4 from another website into your own website, maybe your MySpace page, you might just get that super cool effect you wanted to steal, even if you had no idea what you were doing, and pasted some tags or a script that didn't quite make sense as is. Maybe you closed some tags that you hadn't opened. Maybe you wrote some HTML and you put a paragraph tag inside of an italic tag, even though it's technically illegal to put a block level element inside of an inline element. Or maybe you never closed that italic tag, and the rest of your page from then on became italic. Which was always fun if you saw that on forums back in the day. And differences in how these author errors were handled abounded between browsers. Your page might look fine for you, but it might do something really weird for someone else. So XHTML had a feature intended to put a stop to this tag soup nonsense. It required strict and correct structuring and closing of all the tags on the page. Here we see Firefox refusing to show a page because of its mismatched close tags. Annoying, perhaps, but it would force authors to correct their markup. Of course, perfect markup seems to be impossible to achieve on the web. This kind of thing would happen often, if you pasted or concatenated some old HTML into the middle of your shiny new XHTML page, or if there was a buggy edge case in your HTML generation, however small. But perhaps the biggest reason that XHTML never caught on was that Internet Explorer never fully supported it. You see, to get the strict parsing that was such a supposed selling point of XHTML, you needed to send it to the browser with the correct MIME type of application/XHTML plus XML. But Internet Explorer, yes, even Internet Explorer 9, as we see screenshotted here, would absolutely refuse to display any web page sent with this MIME type. It was pretty much like, whoa, who do you think I am? You must have me confused with a modern web browser, and I promise you, I am not that. So most XHTML pages didn't quite validate anyway, and they didn't have to, because they never used that MIME type. And browsers kept doing their best to make sense of crummy markup, just like they did for HTML. Now, HTML5 took a close look at this. It explored, tested, documented, and codified browsers' corrections for tag soup. Take a look at what happens with that same mismatched close tag that Firefox hated so much in our XHTML when we include this snippet into an HTML5 page instead. That's how a modern browser will interpret it. Thanks to standardized parsing rules from HTML5, it corrects the mismatched tags with no errors, no warnings, and no differences between browsers. Compared to XHTML, HTML5 is easier to write and offers more features with less work. So HTML is once again where it's at. Thankfully, we're not stuck in some sort of loop bouncing between strict and loose markup for web pages. HTML5 is different from HTML4 in some very fundamental ways, and we learned from those failures of XHTML, and we focused on backwards and forward compatibility. Here's a little chart I came up with that attempts to show how HTML5 has more clarity in its specification than anything that came before it, how it is more forgiving of author errors than HTML, and certainly more than XHTML, which had no forgiveness whatsoever, how it's more backwards compatible than XHTML was, and how we have achieved the best cross-browser consistency that the web has ever known. That's all I had for you today. I'm happy to take any questions now, if you have them. Thought I saw a hand. No. All right, well, thank you very much and enjoy the rest of your day.